Hey y'all, CB here at NBS Welding, and our next job we got coming up here, you can see I've got a 1/2 inch plate. This is a 6x10 plate, and I'm getting some marks made on here, and what we're going to be fabricating is basically a drain liner. This is going to go into a parking lot of an apartment complex where there's a drain that was 6 feet deep, built out of block years ago. The block is failing, and the management wanted to try a solution other than cutting the whole thing up and relaying block underground and all of that. So right here we're going to be using several important things here in the shop. I've got the old Airco track torch set up here. I'm going to be using the Hillbilly bridge crane, and I'm also using my plate lifting device there, you see, with the chain and the 2 pieces of angle iron. That thing really works good for dealing with plate like this. And the other thing you might notice, the way I'm cutting, I've got a 6-foot track. I'm making a 6-foot cut. Now, you can't really make a 6-foot cut with a 6-foot track. The machine, it won't reach. So you can see what I'm doing by manipulating the arm here. I can make the full cut with just 1 track. Now, in this situation, you could set up 2 tracks, and a lot of times I would set up 2 tracks on a longer cut, and if a track sticks out of the end of the plate, I'd just put a jack stand on it to support it, or a couple of jack stands. But in the situation where I got to make this 6-inch cut or 6-foot cut with a 6-foot track, it's just as easy for me to manipulate the arm to make the cut. Now, there was a portion here where the shop torches tanks ran out of oxygen, and I didn't want to stop what I was doing, so I just pulled the oxyacetylene lines off the super service truck to get this finished up. That's the reason I opened and closed the door right there. And there wasn't very much cutting left, and I just didn't want to deal with the oxygen tank right in the middle of the whole show. So I just used the tanks and hoses off the super service truck. And then on this last cut, where I'm needing to make a cut that's not quite as long, I didn't bother setting up the track. I just cut it by hand and didn't use the bridge crane on those last couple pieces. Then obviously, you want to clean up your cuts. I am going to be MIG welding this together as far as getting it tacked. And then for the heavy welding, I'll be stick welding. The cleaning doesn't have to be immaculate, but what I'm pretty much doing is the loose dross and slag, I'm getting rid of it. And I did that with the big 9-inch grinder. Now, there's a couple things on the long sides of this that need to be done. I'm marking center and getting some center punch. The drain in the very bottom of this thing is it's a 14-inch culvert. And so that's what water needs to be able to flow through there at the bottom. And so it's going to be okay to have this bottom opened up a little bigger than that. And the way I'm doing that, I got the 14-inch radius marked at the top, but I'm kind of making an A-shaped cut with it. So that's another portion where I'm just using my hand torch and cutting the 1/2-inch plate out that way. And like I said, these are the 2 long sides of it. And so I've got a number 1 tip, and I got 40 psi oxygen, about 10 on the acetylene. You can go down to about 7 on the acetylene, but I find that at 10 I can cut a little faster, and that's more comfortable for me to go faster. So once that's done, it's time to start putting this thing together. And I'm doing a corner fit here, but I've taken some measurements, and I see where I can use up just a little bit of that material to give me that little bit of a ledge that you see there. And I'm using this piece of angle iron as a way to help me to know how to fit this together and try to get it straight as I tack it. Now, I'm using the Hillbilly bridge crane with a plate clamp, and I thought on this job that I might end up snatch blocking the bridge crane. And the reason that a guy might want to do that, if I would have put a snatch block there where my hook's at and then run my hook all the way up, there's an eyelet I can hook it to up on top of the bridge crane. What that would do is it would double your lifting power and cut your speed in half. So I don't really ever run into situations where I need to double the lifting power, but if I snatch block it and cut the lifting speed in half, sometimes it can make it easier to assemble something like this. But I figured I would try it without snatch blocking it, and I didn't have a problem. So I'm glad I didn't snatch block it, because that would have just been wasted time to try and make the lift speed slower when I didn't have any trouble with the lift speed the way it was. So I've got the Arc Captain MIG 205 Pro hooked up here with some 30 thousandths MIG wire. And that's what I'm doing this assembly and tacking with. And I'm going to be I'm putting some welds on, not a whole lot, but I'm going to be lifting it by this. So since I'm going to be lifting it by it, I want to make sure that the thing doesn't come apart on me. And the reason I'm lifting it is obviously just to make it easier on me by putting the other side right over the table like I did that first one. And I'll be repeating the process by setting up the angle iron and picking up the plate, putting it in position. I'm checking my measurements. I've made this just slightly smaller than it needs to be. And that's going to be fine. I might make a couple marks here so that when I put my angle iron up there, I know that I'm not overdoing it on shrinking it down size-wise. But I am able to get a little bit of a lip there, even though I'm doing a corner weld. Normally a corner weld is just corner to corner. But the thing is, like when you measure your parts, you might have one that's bigger and one that's smaller. When you cut that much stuff, this isn't the kind of thing where it hadn't been cut in a milling machine to thousandths of an inch. I might cut something that's supposed to be 32 and I go down through there burning them out like I do real quick and efficiently with the track torch, and I might throw a tape on it and it's 32 and a 16th or 32 and 3/32. And for most of what I do, if it's within an eighth, it's fine. So you'll find times with me where I'm not going to sweat the small stuff. I want to get the job done, and if an eighth of an inch ain't going to hurt it, then the eighth of an inch is not something I'm going to worry about. And so getting this thing tacked up, basically what I'm doing here is a repeat of what I've already done, and then it'll be moving on to the next step. I'll be setting that other plate up here and then getting it squared up. But there's a lot of different things coming into play around the shop that a guy uses that you just, you wouldn't realize how important these things are until they were gone. But, I've got bar clamps and mini come-alongs and finger clamps and scrap material like this piece of angle iron that I'm using. You wouldn't think of that as a tool, but it was a tool in this case, and you just figure out what you can do with what you got. And so this is another situation where, I'm working with what I got, and it always seems like the things I have around are enough. Now, I don't know if you can see on the one, I had a pretty bad cut on, if you look at that corner there at the lower right bottom, see the gap in that. Now I did have to MIG weld that gap shut before I started stick welding, and that was an area where my cut didn't come out very good, and I throwed a tape measure on it and I saw where it wasn't right. But it was something that, as long as if you leave the gap in it where the cut was wrong and get the measurement right and then MIG weld that up and then stick weld over it later, hey, nobody knows the difference. You know, your end result is going to come out the same. Now, where I would have been wrong would have been if I didn't realize that it was like that and I would have corner fit that together, then I would have been making a part that was smaller than I meant for it to be. And that would have been a mistake. So really, it doesn't matter. It doesn't matter how you goof. It matters how you fix your goof. Because if you end up with the correct end result, then, you know, it's no problem. And this is another situation where I got things laying around that I'm going to use, and I realize that I need to spread this apart a little bit. And so I'm gonna use a finger clamp to hold this particular piece of wood up here. And I've got another piece of wood that I'm just going to wedge it in there. And when I straighten it up like that, it opens that up to where I need it. So, you know, that's all I needed to do right there to open that up. And, you know, there's guys that would have went and, you know, freaked out and bought a porta power just to get something like that done. And I didn't need it. I didn't have to go get a jack. I had a couple pieces of wood laying there, and it did what I needed to do. Put the bar clamp on it, got it squeezed together, and now we're moving forward, getting our tack welds made. And so here's another important part of this. As part of my plan to weld this up, I'm going to be using the welding positioner. And you wouldn't have to have a welding positioner to do something like this. And generally, these welding positioners, for my use, generally, I bought the thing to weld pipe. And when I was welding for the drilling industry, I welded miles and miles and miles of pipe on my welding positioner, fabricating pressure pipe. But since I've got a welding positioner in the shop, I've actually got two of them, two different types. I have a welding positioner that's the lathe type, and then I have a tank roll. But I've found other ways to use them, and you're going to see how I'm going to use a welding positioner on this, and it just makes my work more efficient. And it just makes, it not only makes my work more efficient, but it makes it easier on me, and I end up with a better result because of that tool that I've got. Now, what I'm doing right here, I'm on the top and bottom caps both. One of them's going to have a piece of pipe to be held into the welding positioner. The other one is where you saw me putting on that solid rod, and that'll be held by a hook from the hoist, so that when I'm rotating this thing, it's got the support it needs to be safe to rotate it on the positioner. But what you see me doing here, I'm going to be tacking this pipe temporarily on this plate. And now this plate is the bottom, and it will get permanently welded on. That plate that I put on the other end as the top, that's going to get removed because the top of this thing's open, but the bottom, this plate right here will stay. But the pipe that I'm welding on there to hold it in the positioner, that pipe will get cut off and done away with. It's only going to be there because of the welding positioner. And I can rotate this thing on the positioner and get it welded up, and it's going to make it easy to skip around and deal with warpage. Now, when I done this, I put a couple tacks at the top, and my plate was so tight that I didn't have room. I didn't leave any gap when I tacked it, and that plate was a little bit bowed. So when I tried to squeeze the bottom in, my tacks broke. So that was no big deal. It was just, I ended up having to kind of start over and get the thing in position. And since it was bowed a little bit, I found it was going to work out better to put those initial tacks in the middle rather than on the top. When I fit the top tight, and put a tack on it and then had a gap at the bottom. Well, you've seen what happened. I tried to use that 36-inch pipe wrench to close the gap at the bottom, and I broke my tacks loose at the top. Kind of had to start over there, but no big deal. We got her taken care of, and now we're going to be, see, I got the welding positioner set up over here. I'm using the Hillbilly bridge crane to set the box down on the floor, and I've got my, I actually pushed it the wrong way. Now I got to push it back out of the way because I put it in the way of my AC hoist. This Jet 1 ton that I'm going to be using, it doesn't go two directions. It only trolleys one direction. And you would think that in all situations, a hoist would be better off if it trolleyed two directions. But I've found that it is nice, in the case with the welding positioner, to have a couple of hoists that only trolley one way. And what's the thing that's actually nice about it is I generally push my welding positioner around the shop on casters, but when I'm welding with it, I got pins I pull out of the legs, and you can see where I don't have it on casters now. It's sitting right on the floor. It's a lot more stable when it's not on the casters. But all I've got to do when I set up the welding positioner is get it over close to that Jet 1 ton hoist, or the 2 ton is also in line with it. But I pick it up with a hook that I've positioned on the welding positioner, and I'll set the welding positioner down wherever I need it. Then when I pick up something like this item, this drain box that I'm building, it's already plumb bob centered. So when I go to put it in the welding positioner, just by, plumb bob center, it's where it belongs. So that's one time when it's nice to have a hoist that only trolleys one way, because I've realized, like, when I'm fabricating pipe, I can bring my parts in and set them on the floor with a forklift, and any part that I pick up to go and weld on the pipe is going to be a part that's plumb lined up with the machine. Now I'm giving the Arc Captain MiG 250 a thumbs up right there, and I had that thing wide open, and I ran all the root bead welds on this with a 3/16 70-14 structural rod, and it did a great job. And it did that, put them beads in there without fail. And then I decided to run the Arc Captain MiG 205 Pro on the cap. So instead of the 250 amp machine, I'm going with the 205 amp machine. And that ended up being an hour and 19 minutes of burning 3/16 70-14 rod. And so that was quite a task for such a machine that you can pick up with 2 fingers. And this is our cap weld here with the 3/16 70-14 at 205 amps. Before I did a whole lot of slag removal. A lot of the slag just fell off, and there's some of it remaining here, but I'm playing around with the file while I'm filming just to show you when slag comes off like that. Everybody says what a good sign it is, but basically what it means is that you've got to weld free of undercut. Because if you have bad undercut on your welds, the edges of your slag will lock into that undercut. And if that happens, your slag doesn't come off very easy. What I'm using here, I have my 9-inch grinder with a 7-inch diamond wheel. That's a diamond wheel that you get from Harbor Freight, actually, for grinding concrete. And I just laid that flat on the plate, ran it all the way around, knocked all the BBs off, knocked all the buckshot off, and just basically give it a scuff. I did find, you see me MIG weld that one spot. I missed a spot, so I took some 0.30 thousandths wire and did a little doodabbing and fixed my goof. But here's our end result after cleanup. This is a 2-pass corner weld. Like I said, I laid the first bead in there with the Arc Captain MiG 250. the heavy duty arc captain that they've got out. That's the heaviest machine they've got. And then I decided to give the old the new I should say new, not old. Yeah, the arc captain MiG 205 Pro. I did the cap on 205 amps, and I'm still using the welding positioner here while I'm applying the high zinc primer. I'm gonna hit this with the Rust-Oleum red oxide primer. We're not gonna do any kind of showroom finish on the thing, but it's not gonna hurt it a bit to hit it with some high zinc primer, and so that's what I did. And like I said before, that top plate was only there to keep the thing square while the welding was taking place, and to help me hold it in place with the hoist while I was rotating it on the welding positioner. And now we're using the Arc Captain MiG 205 Pro to weld a couple lift eyes inside of here. We're going to need that to get it put in place down inside of the drain. So I took a couple of 3/4 lift eyes, and they've got a 3-inch hole in them. For it's a good size. A 3-inch hole in your lift eye is a good size, because just about all your chain hooks will fit through that hole. I've got some lift eyes I've made or had made that got a 2-inch hole, and for certain things those are nice, but a lot of chain hooks won't fit in them. So here we're getting rid of that pipe that I was using to hold it in the welding position or to rotate it, and then we're going in with I'm gonna probably have to charge them a little extra for that baked on enamel there. So that was like my powder coating I did there, because I put that primer on while that thing was just raging hot. And then I'm going to hit this with another coat on the bottom. Somebody's probably going to gripe at me for getting underneath that thing with it on the forklift, but I just got that done real quick. And now we're on site. One of the fellas, real nice guy, Chris, he's there just cleaning some of the stuff out of the bottom of this failing drain. And you can see how they've been doctoring on this with lumber and concrete, but the old block is just failing. And my buddy Dalton brought out his septic tank truck, and he picked up the drain box with his septic tank truck. This is a truck he uses to set septic tanks in the holes he digs when he's installing septic systems. And he picked up the box at the shop, and he's going to use his unit here to set the box in the hole. Now, they had a 1/2-inch plate set over it, so we had to get that out of the way first. So Dalton's picking it up with the tank truck, and he's just going to, I think he's just getting it out of the way for now, and we're going to kind of bunny hop. But he realized that he wanted to back up a little, and so while the plate was in the air, he backed up and laid the plate there against, and we thought we were going to have to pull the grate out with the tank truck, but I got a chain hooked on it, and I pulled on it, and I was able to slide it out of the way without too much trouble, so we didn't have to hook the tank truck on that. And unfortunately, I didn't get film of the actual box going in the hole. And I didn't run out of battery, and I didn't run out of memory. This was one of the times where the sunshine got the phone hot, where it was sitting there on the tripod, and when they get hot, they just shut down. And I've had that happen before, and it's unfortunate. But I'm glad I got the footage that I got, because you guys can see what we did. Even though I don't have footage of actually setting the box down the hole, you can see what we did. You can see how we did it. We used a tank truck. We set the box in the hole. Now, here was what it looked like when we went to put the grate back. And as you can see here, we've got the best problem we could have if we were going to have a problem. We got more metal than we need. we dug down until we found the solid concrete bottom of that thing, and we set my box in, and you can see here my box is about an inch or an inch and a half too tall. So that's good. Like I say, if you're going to have a problem, that's the problem that I would want to have, because I just brought the super service truck out the next day, and I got my torch and I did a little trim job on her. And, that's a whole lot easier than needing to add metal. Now, if you look here where I'm cleaning this out, you can see what I'm talking about. There's a lip inside of there where that grate goes, and my box is sticking up too high. It's higher than that lip. But that's, like I say, that's a whole lot better than being too low, because, we'll get her trimmed down. Now, the first thing I went about doing was with my magnetic straight edge, and I didn't find that to be the best way to do it. I ended up just standing up and cutting it. But another thing I want you to notice was a torch is not real loud, but one of the first thing I did was put earplugs in. And I want to mention that because you see the way I'm laying right there, I'm taking a risk of fireballs going in my ear. And when I was welding pipe for Columbia Natural Gas back in the early 2000s, one of the welders I worked with actually had a hot ball go in his ear, and he was wearing he had a welding hat on over his ear, but a hot ball went in his ear, and it was so hot that it melted his eardrum, and he's deaf in that ear now. The doctors were not able to do anything to help him. And the one foolproof thing I've found about sparks going in your ear, now guys will put their hat over their ear and do things like that. But if you put earplugs in, the molten metal, when it hits that earplug, it'll cool down so much. It won't burn your ear. So I'm just saying earplugs are for more than just noise. And I've, since that guy lost his hearing, I've really made it a point to just get used to wearing earplugs all the time, whether it's noisy or not. And it's kind of sanitary too, really, guys, if you think about it, because just think about how much you're saving the dirt from getting in your ear. You don't want that crud in there, so I wear earplugs a lot. Now, I got this thing trimmed, and it worked out great. The one problem we had is about the best problem we could have had. Just all it took was to trim that off. The super service truck's looking just as sexy as the socks on a rooster, and we got this thing done. And I want to mention one more time, and always, y'all learn how to work with what you got. That way you always have everything you need.